Children, you have already learned about divisibility rules. Now today I am going to explain divisibility by other composite numbers. Composite numbers are those numbers which are having more than two factors. Okay, so here I took some examples of composite numbers only, like the divisibility by 12, 15, 18 and so on. A number is divisible by 12 or not. We have to check whether it is divisible by both 3 and 4, because we can write 12 as 3 multiplied by 4. So here I took one example, 4740. So we need to check here whether it is divisible by 12 or not. To check it is divisible by 12, we have to check it for the number 3 and 4. As we already have known that how to check divisibility of 3 and 4. So the sum of all the digits of 4740, that is 4 plus 7 plus 4, is equal to 15. And 15 is divisible by 3. So 4740 is divisible by 3. Now another we have to check divisibility by 4. So the last two digits, these are 40. So 40 is also divisible by 4. So finally we got that 4740 is divisible by 12. So in this manner we can check whether the given number is divisible by 12 or not. To check whether a number is divisible by 14 or not, we need to check the factors of 14. These are 2 and 7, because we can write 14 as 2 into 7. So here I took an example, that is 4740, again the same number, whether it is divisible by 14 or not. So we need to check it by the divisibility of 2 and 7. For 2 we can easily find that on one's place there is 0, so this number is divisible by 2. But for 7 it is not divisible by 7. So the given number is not divisible by 14, because if the number is not divisible by any one of the factor, then the number is not divisible by the given number. So here the given number, that is 4740, is not divisible by 14. To check whether the given number is divisible by 15 or not, we need to check it by the factors of 15. These are 3 and 5, because the another factors are 1 and 15, and any number can be divisible by the number itself and the 1. So to check whether the number is divisible by 15 or not, these are the two main factors which we have to check. So here I took example, that is 4740. So we need to check it whether it is divisible by 3 and 5 or not. So on one's place there is 0, so simple, it is divisible by 5. To check whether it is divisible by 3 or not, the sum of all the digits of 4740, these are 15. Sum is 15 because 4 plus 7 plus 4 becomes 15, and 15 is divisible by 3. So the given number 4740 is divisible by 15, because this number is divisible by both 3 and 5. Here I took one more example, that is divisibility by 18. A number is divisible by 18 or not. Here we have to check whether it is divisible by 2 and 9 or not. So I took here example, that is 4770. It is clearly shows that this number is divisible by 2, because on one's place there is 0. So that's why this number is divisible by 2. Now come to check whether it is divisible by 9 or not. So what we have to do to check the number is divisible by 9 or not, we have to add all the digits of the given number. These are 4 plus 7 plus 7 plus 0. It becomes 18. And 18 is divisible by 9. That's why this number 4770 is divisible by 9 also. So the given number is divisible by 2 and 9 both. So finally we can say that 4770 is divisible by 18. So in this manner we can check whether the given number is divisible by the given composite number or not. Children, hope you understand divisibility by other composite numbers. If there is any doubt, you can go through the PPT, or you can revise the video again and again to understand the concept. Thank you and have a nice day.
Tests of divisibility are simple methods used to determine if a given number is divisible by another number or not. We have already learnt some basic tests of divisibility. In this animation, we shall look at tests of divisibility for the numbers 12, 15, 18 and 25. we shall see how divisibility of a number by 12, 15 or 18 depends on divisibility of that number by their individual factors. Let's first look at the test of divisibility by 12. We know that 12 is the product of 3 and 4. So, we can say that if a number is divisible by both 3 and 4, then it is divisible by 12 too. Let's take an example. Consider the number 1152. Let's first test it for divisibility by 3. The sum of the digits of this number is 9, which is divisible by 3. So, the number 1152 is divisible by 3. Now, we'll check the number for divisibility by 4. The number formed by the last two digits of 1152 is 52, which is divisible by 4. So, the number 1152 is divisible by 4. Since this number is divisible by both 3 and 4, we can say that 1152 is divisible by 12. Let's verify this by actually dividing 1152 by 12. As we can see, 12 exactly divides 1152, leaving no remainder. Now, we shall look at the test of divisibility by 15. 15 is equal to 3 multiplied by 5. So, we can say that if a number is divisible by both 3 and 5, then it is divisible by 15. Again, let's take an example. Consider the number 5,54,775. Let's first test it for divisibility by 3. The sum of the digits of this number is 33, which is divisible by 3. So, the number 5,54,775 is divisible by 3. Now, let's check the number for divisibility by 5. The number 5,54,775 ends in 5. So, this number is divisible by 5. Since this number is divisible by both 3 and 5, we can say that it is divisible by 15. Again, we can check this by actual division. As we can see, 5,54,775 is perfectly divisible by 15. Now, let's understand the test of divisibility by 18. We know that 18 is equal to 2 multiplied by 9. So, it can be said that if a number is divisible by both 2 and 9, then it is divisible by 18. Let's consider the number 36,018. First, let's test it for divisibility by 2. Since the number ends in 8, we can say that it is divisible by 2. Now, let's check the number for divisibility by 9. The sum of the digits of the number 36,018 is 18. Since 18 is divisible by 9, the number 36,018 is also divisible by 9. Since this number is divisible by both 2 and 9, we can say that it is divisible by 18. Again, let's check this by actual division. We see that 18 exactly divides 36,018 without leaving a remainder. We have now seen that the divisibility of a number by 12, 15 or 18 depends on the divisibility of the number by their individual factors. Now let's understand the test of divisibility by 25. When we look at the multiplication table of 25, we observe a pattern. We see that all its multiples end with 25. 50, 75, or 2 zeros. So, we can say that if a number ends with 25, 50, 75 or 2 zeros, then the number is divisible by 25. Let's check this with an example. We will check if 45,69,150 is divisible by 25. We can see that the number ends in 50. Therefore, we can say that this number is divisible by 25. Again, let's verify this by actual division. We can see that 25 exactly divides 45,69,150 without leaving a remainder. That was simple, wasn't it? Now why don't you try using these tests of divisibility in some examples on your own?